Well, what did you do? So on 3D.1, you added, subtracted, and multiplied, which was fairly easy. Did we feel like adding, subtracting, and multiplying was fine? Yeah, for the most part. Okay. Division is a little different. So when you're dividing complex numbers, there's a couple things that we have to recall. Okay. We have to remember what are imaginary and complex numbers and how to reduce it. So a complex number means that you have a real plus an imaginary. Okay. Together, this is called a complex number. So you have a real term plus or minus an imaginary term. And that is what a complex number is. Okay. You have to be comfortable with 3D.1, which is where you were multiplying and adding them. And you also have to be comfortable with using the quadratic equation. All right. So with that being said, we're going to do that. Also, you need to remember what a quadratic equation is and what the quadratic formula is. So a quadratic equation means that you're in the form of ax squared plus bx plus c equals 0. That's a quadratic equation. And then remember the quadratic formula. Sing along if you remember. X equals negative b plus or minus the square root b squared divided by 2a. Okay. These are the things that we need to remember. And those are things that we do know, correct? All right. So let's dive in. You can set up your notes however you want. If you're trying to help your notes stay organized, the box method is usually a general way to help you stay organized. It's the entire page, not just a little box drawn in the middle of your page. You're just dividing it the entire page, not just a little box drawn in the middle of your page. Okay, you're just splitting your paper into quarters. Does that make sense? And that's just the way to help you organize. So there's a slide for each box for the most part. All right, in the first box, you are only writing, I'm going to highlight what you're writing. Got it? So in the first box, we're going to write what's a complex conjugate. Okay, the complex conjugate, that is this guy. This is what you're writing in the box. You can write the example if you want, but you're writing what a complex conjugate is. So in box 1, we're calling that our complex conjugate. Are you with me? Okay, what a complex conjugate is, it means that you have an expression that has two terms, and to find its conjugate, your terms are going to stay the same. So notice I have A and I have BI and BI. What changes with a conjugate is the signs. So your terms stay the same, but your operations change. Does that make sense? So your terms are staying the same, but your operations are changing. And that's what makes it a conjugate. So let's practice here, making sure we all understand. So here's the question. The conjugate of the complex expression here. So we have negative 5x plus 4i. Yes. Sure. What would be its conjugate? Why is it 3? The sign changed, but everything else stayed the same. So it would be 3. Easy enough? Do we feel confident in being able to identify the complex conjugate? Okay. The conjugate is an important piece of dividing. All right. The next box, we're going to write the steps of how to divide. I'm going to highlight key words for you to write down, for you to help learn how to paraphrase. We do not have time for you to write verbatim what you see. Does that make sense? So we're going to paraphrase what's happening. All right. So in box 2 is dividing complex numbers. So how do we divide complex numbers? In order to divide complex numbers, so this is our next, you're going to identify the complex conjugate of the denominator. So step 1 is to find the complex conjugate of the denominator. Step 2 is you're going to multiply the numerator and the denominator by the conjugate. Okay. Step 3, you're going to simplify. One thing that we got to remember here is that if you see I squared equals -1. The reason why I squared equals -1 is because when you have I squared, that means you have -1 squared. And when you have when you square a radical, what does it do? it sets it free, right? When I square root, it's its inverse operation, so it cancels out, which is why if you have I squared, it equals -1. And then your final step is to write in complex form. So writing in complex form means your answer should be an A plus BI. So that's what we're going to do. So step 1, we're going to find the complex conjugate of the denominator. Step 2, we're going to multiply the numerator and the denominator by whatever means we need to by the conjugate. Step 3, we're going to simplify. And if we see I squared, what does I squared equal? -1. I squared, U squared. Okay, it equals -1. All right, and then step 4 is we're going to make sure that our final answer is written in complex form, which is your real plus your imaginary. All right, are we ready to dive in? See an example? I believe in you. Ready for our first example? Yeah. Mind your way, are you good? Okay, so you're going to write down in box 3. What is the quotient? So we're writing down 9 plus 12i divided by 3i. So we have 9 plus 12i divided by 3i. Step 1 is you're starting with your denominator. So step 1 is to write the complex conjugate of the denominator. In my denominator, I technically have 0 plus 3i. Does that make sense? Because my real is 0, and is there a necessary reason to write 0 plus? No. So therefore, the conjugate of this would be 0 minus 3i, which means that my conjugate is -3i. Step 2. Okay, how do you feel about step 1? Still good? All right, step 2 is to multiply your numerator and your denominator by the conjugate. So we have 3i times 9 plus 12i over, that's an ugly I, a little funky. Okay, and then we have 3i, -3i, I'm sorry, times 3i. That's step 2. So we're going to go through and multiply. Are we good if I go through? All right. In this case, this is just simple distribution, right? -3i times 9, -3i times 12, -3 times 3i. Okay, so that's going to give us -27i minus 36i squared all over -9i squared. That's step 2. How do we feel about multiplying? You're the best. You can do anything. All right, step 3 is to simplify. You're going to clean this up. All right, we talked about anywhere that you see I squared, it becomes what? -1. So we're going to clean this up. We get -27i minus 36 times -1 over -9 times -1. A negative times a negative is a positive. So we get -27i plus 36 over a negative times a negative is a positive. Okay, you're going to keep simplifying. Can I reduce? Yeah, what can I reduce them all by? 9. I can divide everything by, do we see that? So we keep reducing. -27 divided by 9 is -3. 36 divided by 9 is 4. And 9 divided by 9 is 1. So step 3 is to simplify. Did we simplify? Perfect. Step 4 is to write it in complex form, which is your real plus or minus your imaginary. So in this case, our real is what? 4. And our imaginary is negative 3i. So our answer is, this is our quotient. 4 minus 3i. Okay. This is considered an easier one because your denominator is a monomial. Okay. So if there's questions that you have about the 4 steps here, please let me know. Questions, comments, concerns? All right. Let's do a little harder one in our last box. So we have 5 minus 2i divided by 3 plus 4i. For this example, I'm going to model and remind you guys that you have FOIL, but you also can use the box method if you like to stay a little more organized and see things a little clearer while doing it. Okay. Step 1 tells us to do what? We focus on the what first? Denominator. So looking at our denominator, what would be its conjugate? Three minus 4i. So we're going to take the conjugate. This is the conjugate. Girls, did y'all sign the clipboard? Okay, thank you. Okay. Step 2 tells us we're going to do what with the conjugate? Perfect. We're going to multiply the numerator and denominator by the conjugate. So we have 3 minus 4i times 5 minus 2i. We have 3 minus 4i times 3 plus 4i. Now, me personally, I'm an old school FOIL girl. I will distribute first, outside, inside, last myself away. But however, I've learned that for some people, they need a more visual way of seeing this. The visual way of doing this would be using the box method. So if you choose to use the box method, this would be your prime time to shine. You're going to do the box for your numerator, and you're going to do the box for your denominator. Okay, so my numerator, I have 3 and negative 4i, and I have 5 and negative 2i. My denominator, I have 3 and negative 4i, and I have 3 and positive 4i. And now my job is to multiply, fill everything in. 5 times 3 is 5 times 3 is 15. 5 times negative 4 is 3 times negative 2 is negative 6. Negative 2 times negative 4 is 8. And I times I is I squared. Repeat the process. 3 times 3 is 3 times negative 4 is negative 12i. 3 times positive 4i is positive 12i. And 4i times negative 4i is negative 16i squared. Still with me? So therefore, this becomes, on this one, I can combine like terms, correct? So I have the middle we're going to combine. So we have 15. I don't know why I put that parenthesis there. And then we have negative 20 and negative 6 make what? Negative 26i. And then we have 8i squared. What does I squared mean again? Negative 1. So we have positive 8 times negative 1. That's in our numerator. Are you with me? And then for our denominator, we're looking at the insides here. The middle here do what? Cancel out. 1 is negative and 1 is positive, so they're gone. So we're just left with 9 minus 16 times negative 1. I've now multiplied. Step 3, my job is to simplify. Okay, so we're going to start cleaning this up. So we have 15 minus 26i. A positive and a negative make a negative, over a negative times a negative makes a positive. So that leaves me with 15 combined with negative 8 gives me 7. So 7 minus 26i over, and 9 plus 16 is 25. Can I reduce that at all? No. So step 4 is where you're going to separate your real from your imaginary. So your real is the 7 over 25. Your imaginary is the 26 over 25. Remember, if they share a denominator, they can be separated into two separate terms with their own denominator. And that would be your quotient. All right, that is 3D.2. What are your questions, comments, or concerns?